Hello everyone, I hope you are doing good. In this video, we are going to talk about how to build and run container images on your machine using Podman. So whenever we talk about container images, most of the people, generally everyone talks about Docker images. The container images term is not used as much as the Docker image, which is not quite right because Docker is just one of the technology that supports containerization of application, and there are other technologies that supports creating container images and running those images as containers. So I just wanted to clarify that container images is the right term to use rather than using the Docker images. Now, before we talk about what is a container image and what is a container in itself, we should actually look into OS level virtualization first. So this is the Wikipedia page explaining OS level virtualization. And if I read like a couple of lines here, so it says OS level virtualization is an operating system paradigm in which kernel allows the existence of multiple isolated user spaces instances, right? So you can run multiple isolated instances that would be sharing your operating system's resources, but they would be isolated in a way that anything you do in that user space would be confined to that user space only. And there are different terminologies, right? So most popular one is containers, right? So that's what we are talking about today. We have different technologies that supports container. We have LXC, Solaris containers. Even when we talk about Solaris containers, they go back as far as early 2000s. So it's not a very new thing, these OS level virtualizations, right? Then we have Docker, the most famous one, right? And then we have Podman, which we are going to talk about today. And then we have zones within Solaris. These are called Solaris containers, but essentially Solaris had actually implemented OS level virtualization way before these containers or these things became very popular. I just wanted to make it clear that when we talk about containers, it's just not Docker. Docker is one of the major player in the field of containerization, and when we talk about containerization, mostly people just say Docker, which is a great credit to them in a way. Now if I show you this Wikipedia page for Docker, you can see that Docker runs as a service that can interact with Linux kernel and can use Linux kernel's capability to provide isolated user spaces, right? These are different technologies like libvirch, LXC, systemd, and spawn, with which Docker can interact with Linux kernel and can utilize Linux kernel's virtualization features that we talked about earlier in OS level virtualization. So now that is clear, I hope. Let's go back to our main topic. So in this video, we are going to talk about how we can write a container image file, then build a container image using that file, and then run an actual container using that image in our local machine using the tool called Podman. So obviously, before we start up, we need to have Podman installed on our system. I would try to add a link to the description section of this video that would probably explain to you how to install Podman, and it's not very difficult to do. Now, okay, so before we start the actual work, let's read a little bit about Podman. Like I mentioned earlier, Podman is a technology that allows you to run, build, and share your application using containers, right? So if you see this definition, it says Podman is a daemonless open source Linux native tool which is designed to run, build, share, and deploy application using Open Container Initiative, which is called OCI, containers, and container images. And Podman provides a CLI which is similar to Docker. So if you are familiarized or you have used Docker before, you would find that Podman CLI is very similar. Although there are few differences between Podman and Docker. One of the major advantage of Docker is that it is daemonless. So you don't have to continuously run a process in the background in order for you to use Podman, right? So which makes it more lightweight and secure. The other biggest advantage of Podman is you can run rootless containers using Podman. And this is the biggest security advantage in my personal opinion with Podman, because running a container as root is not secure, because if your container is compromised, you are basically giving root access of your system to the hacker or whoever has access to your container. So that's, one of the biggest advantage I would say of Podman over Docker. And then there are some other minor insignificant differences. I will not be covering them here. So if we read this definition, it says Podman is Kubernetes ready, rootless, secure drop-in replacement for Docker with support for multiple container image format, including OCI and Docker images. So if you have been writing Docker images, Docker files, you can run them as is in Podman. You don't have to rewrite or change anything in there. So just wanted to explain that here. Okay, next thing is before we, start writing a container image and, I show you how to write a static file or, image file instruction and then convert it into an image. For the sake of someone who is new to this, let me just try to briefly explain what is a container image. So you can think of a container image as a static file which has executable code that can create a container on a computing system. So you can think of a container image as a compressed version of everything that you would need to run a container. So for example, let's say you are creating a container image for Java, then that container image would have everything that you would need to run Java, including your OS level binaries, your Java binaries, obviously, and anything else that is needed or required to run a Java application. And same applies for Python or whatever the container image you're trying to create. So in a nutshell, container images are just static files, nothing else. They are compressed. So later on, when we will be downloading the base images from an external repo, you would notice that the podman will try to extract them on my local machine. The other thing to notice about container images is these are immutable, meaning they cannot be changed. So once you have written a container image and you have tagged it, so let's say you created an image for Python and you tagged it v1, then that v1 tagged image cannot be changed unless you delete that tag and recreate the image. And these images can then be consistently deployed in any environment. So you don't have to worry about, how your Python container image behaves on your local machine as compared to a Kubernetes cluster instance running in EKS, EC2, or OpenShift. So you can run the container image consistently in any environment, and that's one of the biggest advantage of using the container image, or you can say biggest advantage of containerizing and distributing your application using container. Now let me clear my screen. Okay, I've cleared the screen. Now we have talked about what is a container image. We have talked about different OS level virtualizations, and we have talked about Podman also. Now, if we say, okay, we have created the image which has everything that we need to run the application, how do we convert, how do we run that image as a container? So that's the next question, right? So that is done using a container runtime, which is also known as container engine. So container engine is a software component that can run a container on a host operating system. That's a very basic definition. So this software component allows you to run your images that you have built previously as containers. So you can write your container image files as instructions, convert them into Docker images or container images, store them in some registry or on your local machine, and with the help of container engines or container runtime, you can run them as a container on your operating system. And if you want to look into some of the examples of container runtime, so we have containerd, CRI-O, Docker engine, Mirantis container runtime. So these are some of the examples of container runtime. So it's not just always, whenever we talk about containers, it's just generally people think it's just Docker, right? So we have different runtimes available that we can use to run our images as containers. Okay, so in this demo, we are going to use Podman to run the images as containers. So like I mentioned earlier, I already have Podman installed on my machine. And let's just notice, like, okay, let's just try to find out the runtime that Podman would use to run the container, right? So that would be interesting to notice. So if I run Podman info command, this gives me information about my Podman, what is the version, build time, and all of other details, right? Now, one thing to notice here, and that's very important and very interesting because this would be a great segue to whatever we talked earlier, right? So we talked about when we talked about Podman's definition, right? So we get to know that Podman allows us to run, build, and share images and containers using OCI runtimes, right? So if you see here, OCI runtime in our case is CR run. So if we look into the examples that we saw earlier, we were looking into container D, CRI-O, Docker engine, and Mirantis container runtime, but we did not have CR run in their example list. But in our machine, OCI runtime is CR run, which is, like I mentioned earlier, is a container runtime, or sometimes it's called as container engine. And whenever later on in this video we create the image and try to run that image as container, CR run will allow us to do so. So this would be the engine we would be using to run our container on this machine. So I hope that makes sense now. And whenever we say I'm running an image, whenever we say I'm running a container using Podman, we are not actually using Podman to run the image. We are using a OCI runtime, which is facilitated by Podman, and OCI runtime is actually CR run, which is actually going to run our container. And if you want to read a little bit more about this particular runtime, there is a GitHub repository under github.com/containers/crun, and this gives you information including documentation about what is CRun and why this is preferred in the newer versions of Podman. So if you see here, they are also mentioning about dependencies required in different operating systems to run this particular runtime. So I will also try to add this link in the description section of this video. So let's come back to the actual topic now. So I've cleared my screen and I am already in my VC Tech Talks Docker folder where I would be creating files today, and there is nothing in this folder yet. So like I mentioned earlier, Podman gives you a CLI which is similar to Docker. So what we can do is, let's say we want to check what are the images available in our system right now. So what we can do is we can just type Podman images, and if you see, I already have two images which I had created a few hours back. So what I'll do is I'll just remove these images so that we can start from the scratch. Okay, I've cleaned up the older images so that we can start from the scratch. And if I do Podman images right now, I'm getting no output. That means I don't have any image on my local machine at this moment. So let's try to write a container image file. So let's say my file. So let's say we are writing a file called my container image file, and this is the file I have opened in VI editor. So the very first thing that we need to do whenever we are writing any container image file similar to Docker file is the from statement. The from statement will be used to define the base image that we would be using to build our image from. So base image is generally an image that has minimum Linux or some operating system specific distribution. So you can have a base image with Red Hat Linux installed. Then you can have an Alpine based base image, Ubuntu based base image, Debian on CentOS, right? So based on the format that we are most familiar with, or let's say you want to run your application on a specific type of base image, or let's say for example you are familiar with running yum and dnf rather than apt, then you would be using UBI base images. And if you are more familiar with using Ubuntu, then you would be using Ubuntu based base images. For the purpose of this video's demo, I would be using UBI based base images. So these are the universal base images created by Red Hat. They are shipped with minimum binaries files that you would need to run a container image, and they are available from Red Hat's registry. So now I have switched to catalogs.redhat.com, and if you see, I've already browsed and searched the nginx 120 because that's the base image I want to use. So this nginx 120 base image would have everything that we need to use and run nginx server. So if you see, it's based on UBI 8 and nginx 120 is the name. So in this documentation, you have overview, security, technical information, and you can even read the Docker file that they have used to create this base image. With the help of this Docker file, you can find things like nginx conf path. So you know that the environment variable nginx conf path would be pointing to your nginx configuration. And then you have script path, etc., etc. So this is the Docker file or the container file that they have used to create the image, and we are mostly focused on how to get this image. So we can get the image using tokens or using the Red Hat login. This particular image though is available without getting authenticated, so you can download it without logging into registries.access.redhat.com. So if I copy the image name from here, and if I say I want to download the image from registry.access.redhat.com, and the repo is UBI8 and the image name is nginx120. Now I can specify tags here if I want to download a specific version of image, but if I don't specify the tag, I'll get the latest tag by default. So that's my base image. Now I know my container file that I'm creating and my container image that would get created later on would be based out of this image. Okay, so let's save this file for now. And now we know that this base image has nginx installed. So for the purpose of this video, let's create a HTML file that we would add on top of the base image, and we would then later on run that as a container, and we would try to access that on our machine. So let me create a file called hello.html. I will just add a text called hello here, and I have saved this file now in my same folder. So now I have two files here in my present working directory. One is called my container image file, which is the image file for building the container image, and then we have a hello.html, which is our application that we want to deploy on top of the base image using this container image file instructions. So let me edit this file again. So now we want to copy hello.html, which is the source, which is in our present working directory, to location on the image, which is under user share HTML. So this is by default the location from where nginx will pick up the HTML files. So that's why we have added this instruction here. We are saying the source is our HTML file and copy it to this particular folder on the image. And now we can specify when the image is run as a container, what should be the first entry point, what should be the first command that the container should run. So in our case, what we're saying, run the nginx server. So that's why we have added this instruction called cmd nginx-g daemon off. That's the instruction to start up the nginx server. So that's pretty much it. If I save this, and just to make sure, if I cat this, we have only 3 lines. One is from base image that we want to use. So we have not specified the tag, so that's why it's going to use the latest tag. Then the instruction to copy the content from our source location, which is in our present working directory, hello.html, to a directory on the destination image that we are going to build using this file. And then we have specified a command line nginx-g daemon off. That is the command that would be run when the container starts up. So this would run with the PID1. So let me clear the screen, and now I'm going to run the Podman image build. So what I'm saying is Podman build -f, which is the file name, which is the file we just created, my container image, and we want to run it from present working directory. So that's why we just said dot and we just run it. So now if you see, this image actually had only 3 steps. So it is running the step 1 of 3. First step was to use the base image. So it is the from base image. Now since this base image is not available on my local machine right now, it is downloading, or trying to download the base image from public registry.access.redhat.com. and if you see, by default it pointed to the latest tag. So right now it is downloading the different parts of the image. One part of the image is already downloaded. So now step 1 is complete, and then step 2 has started, which was to copy my hello.html file to the target folder. And then step 3 was to add the instruction on startup. So now if you see, I got a final image ID, and if I do Podman images, now you can see that my image ID is showing up here, created 22 seconds ago, and size is 445 MB. And I can also see my base image, which was also downloaded as part of my Docker build process, because that is the base image I am using to create my container image, right? So it is created 5 days ago because obviously that was the time when Red Hat might have compiled or created this image. Now this image, if you notice, our image that we created doesn't have a name or a tag. So what we can do is we can run the same command, but instead of running it like this, we can also specify the tag. So we can just say -t your image name, and then colon if you want to specify the tag. If we don't specify the tag, the latest is by default created. So if I run this command again, and this time if you notice, it was very quick, right? It just took few seconds and my image build was completed. The reason was that in this case, what happened, the base image was already available on my system, so it didn't have to download the base image again. And if you see, the step 2 of 3 was to copy hello.html to the target image. Since hello.html was not changed, Podman used cached image from previous run to complete this step. And step 3 was also unchanged, so that's why Podman again used cached image to build this step, and my hello image was created. The only thing that changed was the tag. So a tag and name basically. So my image now, which was earlier missing the image name and tag, now would show up an image name and tag. If I run podman images command again, image ID didn't change because essentially it's the same image, right? We didn't change the instructions, but what we did is we just tagged it and named it. So now it is on my localhost repository called my hello image, and tag is latest, and that's pretty much it. We have written or created a container image file, and using the podman build command, we have converted that image file into a docker image with a tag latest, which has a specific image ID that now we can use to run containers. So this is, part one, where Podman helped us create a Docker image. Now the second step is how do we convert it, or create a runtime container using this image. So let me clear the screen. Right. So if you want to run the container from an image, Podman gives us, similar to very similar to Docker CLI. So what we can do is we can just run Podman run -it, which is in interactive mode, and then your image name. So I just say podman run -it, my hello image. If I run this, my container is up. Now, how do I validate if it is up? So what I can do is I can open a new terminal for my local machine, and I would run podman ps command that would show me currently running containers on my machine. So right now, if you see, it says a container is running with this ID using this image with this command created 55 seconds ago, up from 56 seconds, and name is randomly given boring underscore montalesini. So this shows that our image is running. Now if I want to log into this image, right, so we have converted this image into a runtime container, which obviously, if you remember from earlier, is being run by crun runtime, right? Because Podman is just facilitating. crun is the actual, which is providing us the capability to access kernel's virtualization features. So what we can do is, if I want to log into this container, I can do podman exec -it, and then the podman podman ID, and then the instruction that we want to run, we want to use the bash shell. So if you see here, if I type host name, I get 33D1, which is the container ID. Now, if I go to user share nginx HTML folder, you would notice I now have hello.html file added here, which was the file we had added earlier in our container image file instructions. So this confirms that this is the image that we had actually created, and this image has all the files that we wanted for us to run the application, which in our case is just a single HTML file. Now, problem with this is how do we now access this, right? Because this is running within a container, and obviously container is, if I now type top here, and if I type see the PID1, which is your first process, that is your master process, and the command is nginx-g daemon off. This is exactly the same command that we had in the cmd section of our Docker file. or a container file rather, right? So that command is very important, because that is the first thing that would run when your container starts up. So if you want to, for example, start a application server, right? So your entry point should have instructions to start your application server. If you're, for example, starting a Spring Boot application, so you need to have those Java related command line options in your entry point, so that whenever the container starts, it automatically starts your application. Okay, so that's the thing I wanted to discuss before I talk about next step, which is how do we access this application now outside of Podman, because now this is running in a container. nginx server is running in a container, but that port is not exposed. So if I, for example, try to access it on my local host, I will not be able to access it. Okay, so first of all, let's read the nginx.conf file, and let's see the port in which on which this application is running. So if you see, server is listening on port 8080, and now if I try to access my local host on 8080, obviously it's not running, because there is no way for my local host to know that there is some container running within Podman. So obviously this is not running. So how do we expose our services to outside of containers, right? So what we can do is, let me just control C. If I control C here, you would notice on the second terminal, my image is gone. If I do podman, let me clear the screen. So if I do podman ps hyphen all here, this would show me the containers that were running in the past but may not be running currently, and the docker podman ps command only shows me the currently running containers. So in this case, since we want to expose the port 8080, what we can do is we can just say, we can type -p with podman run, and then the source and destination port. So what we are saying is expose port 8080 from the running container to my local machine. So if I run this command now, and if I do podman ps on my second terminal, now you can see that 3 seconds ago my image has started, and now you see the port. So it is saying earlier the port was null in the previous output. And even if I do podman ps-all, you can compare the two containers, right? So containers IDs are different, image is same, command is same, created obviously in different timestamps. But if you see the port, in the previous container there was no port information. In the latest container, the port 8080 is rerouting to my localhost TCP port 8080, which is because we have added -p instruction here, which is to map the port from container to our local host. So now if I go to my local host on localhost 8080, I'm getting 403 forbidden error, but it says nginx 120.1. That's the version of the server we are running. And if I now access, okay, so we are getting 404 not found. So this is a good error. That means hello.html, we are not able to load it. Let's see in our containers, we'll see the nginx.configuration, nginx.conf file, and see where is the root pointing to. So these are the normal errors you would get. And let's just view the nginx.conf file, and we will search for the root directory. And if you see here, under the server where it is saying it is listening on port 8080 default server, the root directory is under opt approot source, right? So if you go to this directory, this is the root directory where the nginx is taking the configurations from. So what we can do is we can just exit this container. So we have exited the container. We will type Control C here. So let's just confirm that container is down by running podman ps. No container is up. What we can do is we can just update my container image file instruction, and instead of copying the file to user share nginx HTML, we will copy the file to opt app resource source directory. So let's try this. Let's save this file and let's rebuild the image. So in this case, what happened, since the hello.html file got changed, the Podman did not use the cached image. It actually created a new image. Obviously the base image was not downloaded, and since the previous image was changed, step 3 of 3 was also added as a new image, and we got a new image ID altogether. So if I do podman images here now, If you see here, my previous image ID got untagged or removed, and the newer image ID was now tagged as my hello image latest. So now let's run the podman run again. In this case, podman run -p, obviously the ports -it my hello image. Now if we run this, and let's clear my screen on my second terminal, and I'll do podman ps. So in this case, again, my container is up. And now if I reload localhost 8080 hello.html, my hello page is now visible. So this way, what we have done is we have written a container image file, converted that container image file into a container image, and then ran that container image as a container using Podman. Okay, one more thing. So let's say, for example, for some reason, we had some problem with the nginx, for example, conf file, right? In that case, what would happen? The startup instruction in our image, which was to start up the nginx server when the container starts up, would have failed, right? And in that case, if you want to test your image, right, so your entry point is not working, as soon as you try to start the container, it just basically doesn't get started. And you don't want to change your entry point because that's your production image and you're trying to do something that might have broken the entry point. How do you test it? So in that case, what you can do is there is a concept of overriding that entry point. So what you can do is whenever you run the container using Podman, you can type the entry point at the end of the instructions. So in this case, if I do podman ps here, the command for the entry point changed, right? If I do podman ps all of my previous containers were running with bin sh-c nginx command that we had in our entry point when we wrote the docker file, or a container image file, while the latest container has command bash. So that means this container, when it started up, did not try to run nginx by default. So in this scenario, if nginx had some issues, we can still start the container. And now what we can do is we can log into the container which was started with the bash entry point. If I do top here, just to show you, the first PID is running with PID1, which is just the bash command, right? So at this moment, there is no nginx server running. And if I reload this page, nginx is not running, right? So if I had some issue with nginx, what I can do now here is manually try to start the nginx controller. So let's say, I have fixed some files manually and I want to, troubleshoot what's the things are happening. So if you see, I can just run nginx-g in daemon off mode. If I run like this, if you see, my local host is now up. If I do Control C here, although my container is still up, my nginx is down because nginx was started after the container was up manually by me. Okay, so in this video we learned about what is Podman, how we can use Podman to create container images, and then how to run containers using those images created by a Podman. And if you want to override the entry point in order for us to test something, we can also do that. I hope you found this video useful. If any part of this video was informational, or if you learned something new, please do like and subscribe to my channel. Thank you very much for your time. I hope to talk to you soon.